Hello everyone and welcome to our SQL live stream. We are going to share the SQL tips that will take your skill levels from beginner to pro. So stay tuned. Both of these queries are calculating a sum of salary based on department ID. In the first example, we are using an aggregate function and grouping by department ID, whereas in the second example, we are using a Windows function and partitioning by department ID. Do you think both these queries will give the same output? Let's see. On executing the first query, we get 3 distinct department IDs and the sum of salaries of all the records for that department ID. Whereas in the example of Windows function, the rows have not been collapsed based on the department ID. Now the values of each department have a rolling total. The syntax of the pivot function may look confusing, but it is actually as simple as this. You define your table or the table expression, use the pivot keyword, and within the brackets, define your aggregation and define your pivot column and your pivot values within square brackets. The last step is just to add your pivot table alias and you're good to execute your pivot query. Writing the long union all queries to generate some temporary data, why don't you use the values function for a quicker way to generate the same data? The requirement to swap the 2 column values in your data, then a single update statement is all you need. For example, let's say we want to swap the values for columns ID1 and ID2. Then I can simply go and write an update statement and simply swap the 2 column values as set ID1 is equal to ID2, comma, ID2 is equal to ID1. Just execute this query. You will see that 5 rows have been affected. Executing the query again, you will see that all the column values have been swapped. If this doesn't work for your database, then there's another way you can swap the column values. The full video link is in the description and the comments below. Use the string split function to get the delimited value from your string. You pass the delimited string and your delimiter and try to execute this query. You get an error that the string split is not recognized built-in function. In this case, the error is not because of the compatibility level of the database. The error is because of the wrong syntax. To correct this, we need to write select value from the string split function. And here are the correct results. Union all operation gives us the combined output of the 2 queries irrespective of repeating values, whereas a union operation gives us only the distinct values in the output. So a union operation is more performance intensive because it needs to perform an additional distinct scan on the data. The syntax of the pivot function may look confusing, but it is actually as simple as this. You define your table or the table expression, use the pivot keyword, and within the brackets, define your aggregation and define your pivot column and your pivot values within square brackets. The last step is just to add your pivot table alias and you're good to execute your pivot query. If you need to rename a table name in SQL Server, then you need to use the sp_rename system procedure. You need to specify the old table name as the first parameter, followed by the new name, and execute the statement. Trying to select from the old table is an error message. Let's change the name to our new name, and here we have the data. Thank you for joining us and don't forget to subscribe for more. Query has a calculated column called flag department, which is set to 1 whenever the department name starts with H. Do you think we can use this calculated column in a where clause? Let's see. We encounter an error when we try to use it in a where clause saying invalid column name. Next, we try using it in a group by clause and again we get the same error. But when we try to use it in an order by clause, we get the results returned correctly. This is because of the order of execution of a SQL query, in which the order by clause is executed after the select statement and hence can make use of this calculated column, whereas the where and group by clauses are executed before the select statement and cannot make use of the calculated column. Tired of writing the long case statement to implement conditional logic? Then you must use this shortcut using the IIF function. In a single line, you can specify the condition to be evaluated, the output in case the condition is true, and the output in case the condition is not true. SQL developers, we all have to deal with null values in our data, and not handling them correctly can often lead to incorrect results. For example, let's say we want to concatenate the first name and the last name from our employee table. Executing this query is going to give us the full name as null even though we had a first name present for this particular record. LearnSQL.com, which is an amazing online SQL training platform, provides a cool trick to concatenate these string and null values. All we need to do is to use the concat function, pass the first name and last name as arguments, and execute the query. The concat function ignores any nulls and treats them as empty strings. To include the space as a separator in a full name, we can use the concat_ws function, pass the space as a separator, and execute the query. 5 records in the department table. Running a count star on this table gives us the right number of records, which is 5. If we replace the star by a 1, we still get the correct number of records as 5. But if we replace this constant value by the column name department name, we get 4 as the output. This is because count column name does not count the null values in the records. In SQL Server Management Studio, if you want to generate any script for the table, you can simply right-click on the table and select the kind of script you want to generate. Let's say you want to generate an insert statement, then it will give you the insert script. But what if you want to generate this insert script along with the data in the table? You need to go to the database, right-click, go to Task, Generate Scripts, select the tables for which you want to generate the insert statement, go to Advanced, and in the General tab, click on Types of Data to Script. By default, it is set to Schema only. If you click on the drop-down, you can select Schema and Data, say OK, and now it will generate an insert statement for each data record in the table. Say you want to find out the maximum or the minimum of values in different columns. These two functions will allow you to do so. To find the maximum value, you can use the greatest function and pass the column names out of which you want to find the maximum value. In our example, we want to find out the maximum quarterly sales values for our categories. Executing this is going to give you the maximum sales out of the values in these 4 quarters for that category. Similarly, to find the least sales, you can just replace the greatest function with least and execute the same query, which will give you, in turn, the lowest quarterly sales in any of these 4 quarters. And lag functions can help us find the next or previous rows. For example, this query returns the next order date and the previous order date for a specific row. But there are more arguments that can be passed to the lead and lag functions as explained in this course by LearnSQL.com. We can specify how many rows to skip forward or backward by providing a second argument to the lead or lag functions. If a previous or next row does not exist, we are returned a null. Passing a third argument to these lead and lag functions can specify a default value for the nulls. This is a cool SQL trick with which we can mask the email data in SQL Server. We just need to write an alter table statement and alter the column, use add masked with function equal to email. Execute, and a user with just the select access on the table will see the masked data. This is the employee table and we are looking to find all the records where the second last character in the name is A. So we write a query using like and wildcards, and we get an output of records with first names having A anywhere within the name. Here's what we need to do. We need to replace the % by an underscore so that after A, the like command tries to match only one character and not any number of characters. Thank you for joining us and don't forget to subscribe for more. We have ordered the employees by their salary. If we want to rank the employees in the order of their salary, we can use the rank function. This generates the rank for the employees in the order of their salary. The ones with the same salary get the same rank. The next rank of 3 is skipped and the next employee in the order of salary directly gets a rank of 4. If we replace this by the dense rank function, again a rank is generated for the employees and the ones with the same salary get the same rank. But in this case, the next rank value of 3 is not skipped and the next employee in the order of the salary still gets a rank of 3. Do you know how a row number would behave in this situation? Let us know in the comments below. Equal, the nulls will always be treated as the lowest value if you want to sort your data. Here, if we try to order by department name in an ascending manner, the nulls will end up at the top. In SQL Server, unlike other databases, there is no easy way to just put a null's last comment and expect the nulls to end up in the last place. To achieve this, we need to perform a conditional sorting where we check the department name for null values and set it to 1 for a null value, else set it to 0. This will help put the null as the last record. You need to find the employees whose first name starts with either A, N, or R. So you start writing this query with multiple where conditions. This gives you the right results, but there's an easier way to do this. Instead of the multiple conditions, you can define your range of characters within the square brackets. And this query is going to give you the same results. In some scenarios, we might have pairs of data values which essentially mean the same thing. To identify these diverse pairs, we need to use self-join, which means we are going to create a join between two instances of the same table, and we are going to join the ID 1 from the first instance to the ID 2 of the second instance and the ID 2 of the first instance with the ID 1 of the second instance. If we execute this query, we are going to get the two reverse pairs. To identify a unique pair, now we are going to have to add an inequality condition between the two column values. So we are going to say where a.id1 is greater than a.id2. So you can see that this condition is going to be true only for one of these two records, and in our example, it is true for the first record. So if you execute this query, you will get only one distinct output for the same pair value. 3 functions in SQL to round off the decimal values. The round function rounds off the decimal value to the nearest integer. So 57 an example because the decimal part is greater than 0.5. If we make it lesser than 0.5, and execute the round function again, you will see that it rounds it off to 56. The ceiling function rounds it up to the smallest integer larger than or equal to the decimal value, so it will always round it up to 57. The flow function rounds it down to the largest integer smaller or equal to the decimal value, which is 56 for this example. Have you ever wondered that there was an easier way to write that complex SQL query? Then you must know about these two functions that can simplify some of our code. Let's say we want to check that our input value is greater than any of these numbers in the list of values. Now, instead of writing a complex query wherein we first calculate the minimum or the maximum of the series, we can simply use the any function. Using any in the where clause and executing this query is going to give us the desired result because 8 is greater than the minimum value in the series. Let's replace this any by all, which means that we now want to check that our input value is greater than all the values in this series. Since this is not true, we are not going to get any result in the output. Is a case statement in a SQL query where multiple conditions can be true. For example, in this case, both of these conditions evaluate to true. What will be the output? We can see here that the output is the result of the first condition that gets satisfied. Case will exit the loop as soon as it finds a condition that gets satisfied. Thank you for joining us, and don't forget to subscribe for more. Must-know trick and a quick way to append leading zeros to an integer value. Just use the format function and type the total number of integer characters you want in the output. Here 7 becomes 007. If we had a value of 77, you would get the correct value of 077, so 3 characters in the output. Formatting is always tricky, and now you need to extract the period from your date value. So you try to extract the year and the month part and try concatenating those values, and then add some additional code to account for the 2-month characters. There's an easier way to achieve all this using the convert function, and you can avoid all these long lines of code. One of the most useful system stored procedure to get all the metadata information about a table. You just need to pass the table name as a parameter value for the stored procedure. Executing this will provide the metadata information for this object, telling that this is a user table, the columns of this table, the information about the identity columns, indexes, and constraints, and other information like any row GUID columns and the data location on the file group. For the database, first go and download the backup file. Once the download is completed, go to the SSMS, click on Databases, right-click, select Restore Database, select Device, click on Add. Browse to the folder where you have the backup file, select the backup file, just say OK. And once the database is restored, you will get the message that the database was restored successfully. Now if you go to your databases, you will see the database has been restored. The easiest SQL trick if you want to output a limited number of records starting from a specific position. Let's say we want to identify 5 employee records in the order of their salary starting from the employee with the 3rd highest salary. Now the obvious approach would be to use the Windows ranking functions and use either subqueries or CTEs to get the desired output. But instead, we are going to use offset to skip the desired number of rows and then use the fetch command to fetch n number of rows from the offset position, which is going to give us an output of 5 employee records starting with the employee with the 3rd highest salary. This can be especially useful for pagination or when dealing with large volume of data records. You can use the merge statement to perform an insert and update using a single command. For example, we are going to insert or update records in the dim products table that already has 3 records from the staging products table. The first record is an update on product price and the 4th record is a new record. Using the merge statement, we have to define the dim products as the target and the stage products as the source. Next, we need to define the key on which we are performing the match. Then we are going to define 2 conditions, when matched and when not matched. We are going to add by target here because we are trying to find the match on the target. If it is a match, then we are going to update the value and set the target product price is equal to source.product price. If it is not matched, then we are going to insert the 3 values from the source table. After executing this query, these were our original records in the dim product tables. And after the merge query, we have the updated product price and the new record inserted as well. Many SQL developers are aware of this extremely useful output clause which can help us identify the inserted, updated, deleted values in any of our DML operations. For example, I created this simple table with 3 columns: key ID, key name, and key value. I can write a simple insert statement to insert some records in this table. But if I add this output clause, I will be able to find out the inserted key ID values for the new records. Next, if I write an update statement to update the key value of all those records where the key name is less than or equal to 13 and want to find my updated and the original values, I can again use the output clause. Your inserted.column name is going to give me the updated values and the deleted.column name is going to give me the original or the old values. As we can see here, these were the original values which have now been updated to this value. Similarly, we can use it in a delete statement to output the values of the records that were just deleted. The unlag functions can help us find the next or previous rows. For example, this query returns the next order date and the previous order date for a specific row. But there are more arguments that can be passed to the lead and lag functions as explained in this course by learnsql.com. We can specify how many rows to skip forward or backward by providing a second argument to the lead or lag functions. If a previous or next row does not exist, we are returned a null. Passing a third argument to these lead and lag functions can specify a default value for the nulls. Thank you for joining us and don't forget to subscribe for more. Table with the start date and the end date columns. Logically, the end date cannot be lesser than the start date, but for record number 2, we see that the end date is lesser than the start date. To restrict these invalid records from getting inserted in a table, we can add a check constraint to always validate that the start date is less than or equal to the end date. Executing this statement is going to give us a conflict because we already have an invalid record. So we are going to delete the record as we are going to attempt to insert a record which has the end date lesser than the start date. And we are going to get an error with the conflict on the check constraint. If we make the start date lesser than the end date and try to insert the same record again, we are going to get the correct results. Sometimes as SQL developers, we need to create a table with the same structure and data as an existing table. In SQL Server, we can achieve this by writing the select star into statement. Just give the new table name from the original table. Now you can see that we have a new table department 1 with the same structure and data as the original table. We can also add a filter condition in the where clause or select only specific columns to create the new table. The data that we need to insert in a database table may contain single quotes. For example, we need to insert the last name O'Hara in the person table. O'Hara contains a single quote after the initial O. The insert statement running this query gives us an error message. LearnSQL.com has this amazing SQL tip in their cookbook that can help us insert data with single quotes in SQL. We simply need to escape the quote in our data with another single quote, and now executing the insert statement will insert this data in our table. The table contains 5 distinct department names. Observe that one of the values is null. We write a SQL query to perform a count of records where the department name is not equal to HR. Executing this query is going to give us a result of 3. Going back to our data, we would have expected a result of 4. This is because the SQL query is only counting records where the result of this where condition is true. With a null value, the result is a null and therefore it is not counted in the final output. To fix this, you can use either the isNull or any null to value function to replace a null value with an empty string and then perform the count. Find the order of the employees in terms of increasing or decreasing salary, we can use 3 functions. We can use the row number function, which will create a row number for each record in the increasing order of employee salary with distinct values for each record. We can use the rank function, which again will order the employees in the increasing order of their salary, but creates the same rank value for 2 employees with the same salary. We can also use the dense rank function, which again creates the same rank value for employees with the same salary, but differs from the rank function in creating continuous series of values for the dense rank as compared to the rank function, which skips a rank value in case the previous records have the same value and the same rank. In some scenarios, we might have pairs of data values which essentially mean the same thing. To identify these reverse pairs, we need to use self-join, which means we are going to create a join between 2 instances of the same table, and we are going to join the ID 1 from the first instance to the ID 2 of the second instance and the ID 2 of the first instance with the ID 1 of the second instance. If we execute this query, we are going to get the 2 reverse pairs. To identify a unique pair, now we are going to have to add an inequality condition between the 2 column values. So we are going to say where a.id1 is greater than a.id2. So you can see that this condition is going to be true only for one of these two records, and in our example it is true for the first record. So if you execute this query, you will get only one distinct output for the same pair value. To find a string value in a customer's address which is split up into multiple columns like this. So you end up writing a tedious SQL query like this, wherein you check each column for that particular string value. This query is going to output all the customer IDs who have main street in any of the address lines. Did you know that there's an easier way to achieve this? You can use a where clause, put the string value that you want to search, use the in clause, and specify all the columns as a list of values. And here's the output. If you want to identify the alphanumeric and the non-alphanumeric strings in your data, you can use the wildcards with the like keyword. To filter on the alphabets, we can define the alphabetic range within the square brackets. Since we are identifying the alphanumeric data, we need to add the numeric range as well to this data. Put it within quotes and the % sign and execute your query. You will see that you've got all the records which have any alphabets or numbers in them. Next, we want to identify those records which have any characters which are not alphabets or numbers. To do this, we need to add the caret sign here so that now we identify any character which is not within the alphabetic or the numeric range. Executing this query is going to give you that one record which has a special character in it. Since we are interested only in selecting records which are valid records as per our criteria of being alphanumeric, we can just add a not here and get the desired records. You do not need to terminate the CTE definition with a semicolon. While defining multiple CTEs, we need to use the with clause only once in the beginning for the first CTE and not for the following CTEs. You are not allowed to use the order by clause in a CTE. The only exception is when you need to select the top n rows. The select statement should be the first statement while defining a CTE. The CTE definition can be followed by a single select, insert, delete or update statement, but keep in mind that these statements are going to affect the data in the base table. To perform a division operation, we get only the integer part of the result in the output. To work around this, we can cast the numerator as a float and perform the calculation. Happen to encounter exponential data in your data source, trying to assign this exponential value to a decimal column is going to result in an error. To fix this, we first need to convert our exponential value into a float data type and then assign it to a numeric column. Let's use the end of month function to get the last day of the current month. Then use the second argument and go back by 2 months by giving -2. So we go back to April and the last day of April is 30th of April. Then use the data add function to add 1 day to this, which is going to give us the next day, which is going to be the first day of the last month. So for this employee data, let's say we want to create a manager flag in which if the value of manager ID is greater than equal to 5, we want to flag it as 1. Otherwise, we want to keep it as 0. So the function that comes to my mind is the case statement. Wherever the manager ID value is greater than equal to 5, the manager flag is set as 1. So what we can do over here is we can write an IIF function, so kind of an if function, wherein first of all, we will specify our expression, the comparison that we are performing. So this condition that we have over here basically in the when clause. So I'm just, if this condition is going to be true, value of 1, and the next argument is when this condition is not true, what is the value that I want to assign? So that is going to be a 0 value. That I've got the flag as 1, otherwise it is 0. There might be times when a database performance is affected by some long-running SQL queries which might have been initiated by different source applications and need to be killed in the backend. The easiest way to identify and kill these queries is by using the stored system procedure sp_who2 and pass the parameter value as active, execute, identify the SP ID of the query that you need to kill, and just use the kill command and pass along the SP ID to kill that query. To find all the tables in the database that contain a particular column name, you can use the information schema.columns table. You can just filter on the column name or run a like statement on the column name, and you will get all the information related to the table catalog, table schema, and table name, which contain any column which has the word product in it. In our last SQL tip, we saw how we can use the generate series function to generate a continuous series of numbers. We can also use this function to generate a series of continuous date values. So we are going to generate values for each day of this year. Knowing that 2024 is a leap year, there are going to be 366 days in this year. Next, I'm going to use the date add function to add each day generated by the series to my start date. In the result set, we can see that our values actually start from the 2nd of January as we already added one to our first day. So to fix that, I'm going to start generating my series from 0 all the way till 365. And now I have 366 records in my output starting from the 1st of January 2024 all the way till 31st December 2024. We all have been using the lag function to get the previous record's value. But do you know that there are two more arguments that can be passed to the lag function to make it even more powerful? The first argument is the offset, which defines by how many records we need to go back. So if you want to go back by 2 records while obtaining the previous record's value, you can specify the offset as 2. The next argument is default, which allows us to specify a default value when there are no previous records for the current row. So instead of outputting these nulls, we can define a default date in our example to replace the nulls. When we have a string value with some trailing spaces, do you know the length function will not be counting the trailing spaces? To work around this, we can try concatenating a single string character like a pipe to the original string and then subtract -1 from the overall length. Not many SQL developers are aware of this extremely useful output clause, which can help us identify the inserted, updated, deleted values in any of our DML operations. For example, I created this simple table with 3 columns: key ID, key name, and key value. I can write a simple insert statement to insert some records in this table. But if I add this output clause, I will be able to find out the inserted key ID values for the new records. Next, if I write an update statement to update the key value of all those records where the key name is less than or equal to 13 and want to find my updated and the original values, I can again use the output clause. Your inserted.column name is going to give me the updated values and the deleted.column name is going to give me the original or the old values. As we can see here, these were the original values which have now been updated to this value. Similarly, we can use it in a delete statement to output the values of the records that were just deleted. This is one of the most useful system-stored procedure to get all the metadata information about a table. You just need to pass the table name as a parameter value for this stored procedure. Executing this will provide the metadata information for this object, telling that this is a user table, the columns of this table, the information about the identity columns, indexes, and constraints, and other information like any row GUID columns and the data location on the file group. If you have a delimited string of values and you need to extract each of this string and convert it into a separate row, then the best way to achieve this is using the string split function. To use the function, we need to write the below query. Select value from string split delimited string, and the delimiter. And you get the values as separate rows. Struggling with unwanted characters at the beginning or end of your string? Then you can use the trim function. Use trim with leading to remove characters from the beginning of the string, trim with trailing to remove characters from the end of the string, and trim with both to remove characters both from the beginning and the end of the string.
You'll see that my output has the same issue. The month name has been sorted alphabetically in the ascending order, whereas I actually wanted it to be in the order in which it appears in an year. So this is not the right column to be used in this case. The right column that I can use is month, because it is giving me the month number. So if I use this in my case statement and execute this query again, you'll see that they have been sorted in the correct order.
While working on databases, it can be a challenge dealing with special Unicode characters in our data. Let's assume we have this data with an invalid character towards the end, and we decide to insert it into a wildcard column in our table. Trying to view this data in the table tells us that the last Unicode character has not been interpreted correctly. To fix this, we need to insert the data in the correct data type. In our scenario, we are going to change the data type to an AND varchar, which is a Unicode data type, and now try to insert the data. We notice that our issue has still not been fixed. This is because we are inserting text data into an AND varchar column, and therefore we need to use the N prefix to inform the database that our data contains Unicode characters. This fixes all our problems, and we can now see the correct data in our table. We all are used to the select star into statement to create a new table whose structure is similar to an existing table. But this statement also copies the data from the original table into the new table. But what if we do not want to copy the data and want to create an empty table instead? In that case, we can add a where clause with a condition 1 equal to 2. Now this condition is always going to evaluate to false, and therefore no rows will be selected from the department table. When you execute this query, a new table department 1 will be created with the same structure as department table, but it will be an empty table with no records in it. One of the most common source data issues is when a user enters too many spaces while typing in a value. This can cause many downstream issues like truncation errors and incorrect displays. And unfortunately, just writing a simple select query is not going to tell us which of those records have those extra spaces. You might think that a trim on the column might give you the incorrect record, but length and trim functions do not work correctly with trailing spaces. The trick here is to add a single character at the beginning and the end of the string and execute the query, which makes it obvious which is the record with those extra spaces. The first argument that you need to pass is in which terms you want to increment. So you want to increment by days or by years, by months. So let's say we want to increment by a day, and then you have to just provide the date on which you want the increment to be applied. So let's just say I want to increment on the current date, and by how many days you want to increment. So that is the middle argument which we just missed. So let's say I just want to increment by a day. So if I execute this query, I'm going to get the output as 18th of March, which is the next day. Now instead of this, I could do a month, which is going to increment this value by a month. So if I run this, I'm going to get the value as 17th of April, which is the same date the next month, and the time remains the same. Thank you for joining us, and don't forget to subscribe for more.